Okay, hello, you're welcome to my channel. In this video, we want to find the antiderivative of x raised to the power of x divided by the ln of x. Alright? Okay, great. Let me work on this function a little bit before we go ahead and do the integration. So we have the function to be x raised to the power of x divided by the natural logarithm of x, right? Now when we are doing integration like this, we don't really like the base to be the variable we are integrating over. This is over the x variable, so we want to change this to some number. All right, when we put a number here in the base, if at all, it will make sense. It will be a lot more easier. All right, so that's to say I'll try to change this to become a number, this base. Well, if I'm making use of the logarithmic property, which tells us that e raised to the power of the natural logarithm, where is the natural exponential function, raised to the power of the natural logarithm of anything will be that thing. So if I'm putting this inside here, that will be x raised to the power of x divided by ln of x, right? That means these functions, which are inverses of each other, by composing them together, right, the composition will produce the identity, which is what we have there. So this and that are equal. This is equals to that, right? Good. So from here we can make use of the logarithmic property, which tells us that we can put this power here out front and multiply with the logarithm. We're going to have e raised to the power of this, right, x divided by the ln of x. Then we multiply it by ln of x, right? And when we do that, we see this and that will cancel out because they are just the same, right? And that means we're going to have e raised to the power of x. So this function reduces to e raised to the power of x. So that's very nice. In this place, you're going to have e raised to the power of x. Wow. Look at that. This is very easy because the antiderivative of this stays the same, right? Nothing happens to it. So if you like, you can add an arbitrary constant. But let me do a little thing. Let me rewrite it as its original, using the original function. From here, we see that they are the same, right? So that means we're going to have e raised to the power of x, which is just x raised to the power of x divided by the ln of x, okay? Divided by the ln of x. And I can add an arbitrary constant, and I call this the antiderivative of that function. So as you can see, this function is there. So it's just like saying that this and that can cancel out, and we are just having this. Then we must always add an arbitrary constant. That's nice. But notice something. From this question we just solved, does it mean that this is the same thing as e raised to the power of x? Are they the same? Right? Well, they are the same, but not everywhere. Okay? Look at this function. This function is an exponential function, natural exponential function, in fact. This function exists for all real numbers x. Okay? As the curve goes like this. Right? As x tends to infinity, it goes on like that, and then touches this here at x equal to 0 and goes up like that. But this function is equals to that, but this function does not exist when x is equals to 1. Take note, if we have x to be 1, that will be 1 raised to the power of 1 over logarithm of 1. The logarithm of 1 is 0. If you are dividing by 0, you have an undefined notation, right? So this does not exist at 1. This does not exist at 0. 0 raised to some power, 0 over logarithm of 0 doesn't even exist at all. So this does not exist at 0, and this is a base x. The base, if you want to remain on the real numbers, the base should not be a negative number. So that is to say, at negative numbers, right, that is towards the left hand side of 0, this function does not exist. But this one exists for all real numbers, positive and negative, including 0. So that means these two are not exactly the same, right? But if we are looking at maybe from 0 to 1, the open interval, and then maybe from 1 to positive infinity, then we can look at this as they are the same. All right, so when you're looking at this integral, you be careful. All right, the integral is correct, okay, but the functions are not exactly the same. They are only equal in this domain, right, the union of these intervals. But outside this, one will not exist while the other will exist. Okay, that's very nice, but this right here is the antiderivative of that function. Okay, thanks for watching, and please subscribe to my channel.